Very good evening, all of you. Hope you all are doing well. Let's start with today's session. In yesterday's session, what all things we have covered, let's take a quick recap of it. Yesterday, we completed with remaining literals, that is, character literal. Then, about escape sequences, I told you, string literal, right? And then we started with concept called data type. We in detail discussed about what a primitive data type, non-primitive data type, right? And then we started with primitive data type and its classification I gave you, right? So today we are going to discuss in detail about all the primitive data types. Okay, just to recall back, yesterday I gave you this classification. Primitive data type, in that one special data type is Boolean. Remember, Boolean is such data type which cannot be converted to any of this, and any of these data types cannot be converted to Boolean. It's a special type. Then in numeric, we have whole numbers, that is integral type, and floating type. In floating type, float and double. In integral also, we have unsigned, that is character. Character is by default unsigned. Now, some may say in character we store graphical symbols A, B, Z, alpha, beta. So how come it is integral? Remember, those are only graphical symbols on the screen. But in computer's memory, they all are stored in their equivalent code. Every character will have its equivalent code. Getting? If it's small a, it will have its code. Understanding? And then that code is a number only. So ultimately that number only will be stored in the memory. Okay, but it is by default unsigned, right? And these four which come under integral, they are signed. Now we'll say what is the difference between signed and unsigned. When we say it is signed, whatever is its capacity, okay, whatever capacity, half will be positive and half will be negative. And if it is unsigned, then in that whole capacity, everyone is positive. Okay, I hope that is clear. And remember, Java is having 8 primitives, 8 keywords. You cannot use them in combination. Like in C, we can use short end or long end. Such combinations are not there. 8 keywords, they are used individually only. And for every 8 data types, there is corresponding wrapper class. If you want to represent the primitive as an object, then you have to use that wrapper class. Okay. Now we will talk about all these data types in detail. In that, the first category I'm going to take, that is integer type. Okay. Remember, in integer type, they all are for whole numbers. Whenever you want to store whole numbers, positive or negative, go for integer type. Okay. Remember, they are for whole numbers, but they are signed. They will have positive value also, negative also. Okay. But before proceeding with this, who all come under this category, what is their size, then minimum value, maximum value. Before that, I just want to tell you all integers are stored in memory in their equivalent binary form. Like you have 35 minus 75, whatever it is, 1262. Each and every number in computer's memory is stored in their equivalent binary form. Like if it is 32, so 32's binary will be there. Like this is 0th bit, 1 bit, 2 bit, 3 bit, 1 nibble. Okay, 4 bits make 1 nibble. 2 nibbles make 1 byte. Okay, 4th bit, 5th bit, 6th bit, 7th bit. Now I want binary of 35. So I'll take 2 raised to 5. 2 raised to 5 is 32. In 5th bit I'll put 1. So it is 2 raised to 5, 32. 3 more I need. So 2 raised to 1 is 2. And 2 raised to 0 is 1. 2 raised to 0 is 1. So 2 plus 1, 3, and this 32 makes 35. Remaining all are 0. Okay, this is binary of 35. Same way there will be binary of 1262. Same binary of minus 75. But now the question is how this negative is stored. Positive I understood, right or no? 32 means I've converted it into binary. You can convert in this way also. It is very lengthy process. Divide by 2. Getting? So 16 2s are 32. Getting? 16 2s are 16. Instead of 16, 17 I'll take. 17 2s are 34. Remainder 1. Then 2 8s are 16. Remainder 1. Then 2 4s are 8. Remainder 0. Then 2 2s are 4. Remainder 0. Getting? 2 2s are. And then finally 2 1s are 2. Remainder 0. Okay. Now if you collect this all remainders from bottom you have to consider 1 0 0 0 1 1. Do you see this only? 1 0 0 0 1 1. Okay. So instead of doing that, I've just done it by trial and error. The fifth bit, that is 2 raised to 5 32, 2 raised to 1, that is 2 34, and 2 raised to 0 1 35. Okay. Now the question is how the negatives are stored. Always remember negatives are stored in their 2's complement form. Okay. Now we'll say what is 2's complement. Actually it is 1's complement plus 1. Okay. Now you'll say what is 1's complement. Wherever you get 0 bit, make it 1. Wherever you get 1, make it 0. 0 is made 1 and 1 is made 0. That is toggling. Toggling the bits. Bits are toggled. After toggling, you get 1's complement. And in that you add 1, you get 2's complement. Instead of doing this lengthy way, there is one shortcut way. Whatever binary number you have, 0 1 0 1, 1 1 0 0, and someone tells calculate 2's complement of it. Always remember 2's complement of this you can calculate in a very easy way from LSB till you don't get first one. Keep it as it is. Okay. From LSB till we don't get first one. Keep it as it is. And then toggle it. Then make 1 as 0, 0 as 1. Understanding? Okay. From LSB till we don't get first one, keep it as it is and then toggle. This is directly 2's complement. If you want, you can do it by 1's complement and add 1 in it. Getting? If I take 1's complement, I'll get 1 1 0 0 0 1 0 1. And then when I add 1 in it, you'll get the same thing. 1 plus 1 is 0, carry 1. 1 plus 1 is 0, carry 1. Now 1 plus 0 is 1. And then as it is, everything will remain as it is. Okay. So now quickly, I told you that whenever you have any integer, how it is stored in memory, equivalent binary. If it is a negative number, binary only, but in 2's complement form. Okay. For examples, yeah, like if you are having 35. So just now we converted into binary. 0, 1, 2, 3. Okay, 4, 5, 6, and 7. 1 byte suppose I am taking. So 2 raised to 5 is 32, 2 raised to 1 is 2, 2 raised to 0 is 1. This is positive 35 binary. This is binary of plus 35. But now someone if tells you represent minus 35. What you have to do is whatever is plus 35 is binary, take 2's complement of it. Plus 35 binary, take 2's complement. So what will be 2's complement? From LSB till I don't get first one, I'll keep it as it is. This is first one. After that, I have to complement 0, 1, 1, 1, 0, 1, 1. This is binary of minus 35. Remember. This is binary of plus 35 and this is binary of minus 35. Correct? And you can recognize it that whenever in the MSB, this is MSB. MSB means most significant bit. This is LSB, least significant bit. So in MSB, whenever you get 1, the number is negative. Whenever in MSB you get 0, the number is positive. Always. Whenever MSB contains 0, the number is positive. Whenever MSB contains 1, the number is negative. So I hope quickly you understood it, that how a integer is stored, equivalent binary. Negative number, whatever is its positive binary, 2's complement of it. Correct? And when the sign bit is 1, it is negative. Sign bit is 0, it is positive. Okay. Now moving ahead, who all come under integer category? They all are signed. Okay. So for example, suppose, example, I am taking 3-bit, okay, signed integer. Now, when I'm saying signed integer, meaning whatever is its capacity, half will be positive, half will be negative. See here, 3-bit signed integers. Okay. Now tell me, when it is 3-bit, means what will be the total possible numbers formed? 2 raised to 3, that is 8. Why 8 numbers only? First of all, tell me, in every bit, I can store only 2 digits, 1 0 and 1 1. So every bit, if it is 3-bit, 1, 2, 3, everywhere I can store 0 or 1, 0 or 1, 0 or 1. So everywhere 2. And like this, how many digits are there? 3 digits, I mean 3-bit. So 2 raised to 3 is 8 combination. I can show you all the combination. 0 0 0, 0 0 1, 0 1 0, 0 1 1, 1 0 0, 1 0 1, 1 1 0, and 1 1 1. This way, how many combinations are formed? 8, because there are 3-bit. In reality, we don't have 3-bit data. Data is always minimum 8-bit. Okay. The data is always minimum 8-bit. But for example, I'm showing. Consider your data is 3-bit. Signed integer. Signed means you are remembering whatever the capacity of 3-bit will be, in that half will be positive half. So how much is the capacity of 3-bit? 2 raised to 3, 8 numbers, means 8 integers. From 8, 4 are positive, 4 are negative. Getting? How to recognize? Just now I told you, whenever the sign bit means MSB, is 0, the number is positive. So see here, 0, 0, 0. How much is the decimal? 0. 0, 0, 1. The decimal is 1. 0, 1, 0. This is 2. Right or not? 0th bit, 1th bit, 2 bit. So at 1th bit, we have 1. That is 2 raised to 1. 2 raised to 1 is 2. So this is 2. Okay. Now this is 2 and 1, total 3. But, so in this 8 positives, 8 numbers, 4 are positive. That is 0, 1, 2, 3. Now remaining 4, you can see the sign bit is what? 1, guys. The sign bit is 1. Means from here, it will start treating all the numbers as negative. Why? Because it is a signed integer. As it is a signed integer, its capacity will have half positive, half negative. Okay. So from the sign bit start coming 1, from there it will start treating negative. So what is this binary? 1, 0, 0. What is 2's complement of it? You have to take first 2's complement and then decimal. 2's complement will be same. 0, 0, 1. I told you now how to take 2's complement. From LSB till we don't get first one, keep it as it is. And after that toggle, but after that we don't have only, because our data is 3-bit only. So from LSB till I don't get first one, I kept as it is. Now it's decimal. This is 1, this is 2, this is 4. It is 4. But remember, I will not write 4. I'll write -4. Because I have not got the decimal from the direct binary. I have got it from 2's complement. This was your original binary. Then you created 2's complement, and then 2's complement decimal when you get, you have to give sign minus. Similarly, next binary is 101. Again, your sign bit is 1. So it is a negative number. Again, take 2's complement. 1, 1, 0. From LSB till I don't get first one, I'll keep it as it is. And then complement 0 will become 1, 1 will become 0. This is how much? This is 1 and this is 2. Total 3. But I have to write it as minus 3. Similarly, next is 1, 1, 0. So what is 2's complement? 0, 1, 0. This is 2, but I have to write minus 2. And last is 1, 1, 1. From LSB till I don't get first one, keep it as it is. Then complement. How much is the decimal of this? 1, but I have to write minus 1. So can you see 2 raised to 3, total 8 numbers, from which 4 are positive, 4 are negative. Means in this, you can observe 0 doesn't come twice. If 0 is going in positive, the negative start with minus 1. If you check this, it's like this. The highest is 3 and the smallest is minus 4. Means if you take number line 0, 1, 2, 3, these are 4 in the positive side, and negative doesn't have 0, therefore negative start with minus 1. So minus 1, minus 2, minus 3, minus 4. Can you see total 8, from which 4 positive, 4 negative. Getting? So in this, what I wanted to say is clear to you, that if your number is a signed integer, okay, and let it be, it is of any bit. If it is of n bit, so its total capacity will be 2 raised to n. In that, half will be positive, half will be negative. How you start knowing that it is a positive number? When the sign bit is 0, it is positive. When sign bit is 1, it is negative. But how do you convert negative to decimal? By taking its 2's complement. So take the 2's complement, okay, then take its decimal and put minus sign. Okay, from this we observed that if our number is a 3-bit signed integer, our minimum value is coming out to be 4 to maximum value is coming out to be 3. I can represent this in 2 power form like this: 2 raised to 3 minus 1 to 2 raised to 3 minus 1 minus 1. Minus 1 down I'm writing. See here, 2 raised to 3 minus 1. 2 raised to 3 minus, so 3 minus 1 is 2. So 2 raised to 2 is 4. Here also 2 raised to 3 minus 1 is 4, and 4 minus 1 is 3. So in general, as it was 3-bit, I wrote 3 minus 1. If it is n-bit, can I generalize, write formula 2 raised to n minus 1 to 2 raised to n minus 1 minus 1, where n is the number of bits in that data type. N is the number of bits in that data type. Okay, so in general, we can take formula like that: 2 raised to n minus 1 to 2 raised to n minus 1 minus 1. Okay, so in integer category, we have 4 data types. One is byte, which is 8-bit. As it is 8-bit, what will be the minimum value? 2 raised to 7, because n is 8 now. So 8 minus 1 is 7. 2 raised to 7 minus 1. Okay, I can justify this also. Okay, how it is. See, how many in byte data type, how many bits are there? 8-bit. If it is 8-bit, so how many total numbers will be formed? 2 raised to 8. Now 2 raised to 8 is 256. Now in 256, 128 are positive and 128 are negative. 128 positive, 128 negative. But positive start from 0. Therefore, it will be 0 till 127 only. So 0 to 127, 128. And negative will be from -1 to -128. Getting? And you can check here. 2 raised to 7 is 128 minus 128. And 2 raised to 7 is 128 minus 1, 127. So minus 128 to plus 127. Total 256 only. 128 negative, 128 positive. Getting? Here also all 8 combinations, 8 bits 0. Till it will go on making all the combinations till, like here it is 1, then it is 1 0, then it is 1 1, then it is 1 0. Like this last value will be what? 1 1 1, 1 1 1 1. Understanding? Okay. So in this also remember, when the sign bit is 1, they all are negatives, and when sign bit is 0, it is positive. Now similarly we can write for short. Next is short data type. Short will take 16 bit. So 16 bit means minus 2 raised to 15, because n is 16, to 2 raised to 15 minus 1. So 2 raised to 16 makes out 64,000. And 64,000 means 32,000 positive, 32,000 negative. Then comes int. Int takes 32 bits. Okay, so it is minus 2 raised to 31 to 2 raised to 31 minus 1. This comes out to be plus or minus 2 billion. 2 billion. And we have long, which is 64 bit. This is minus 2 raised to 63 to 2 raised to 63 minus 1. Why? Because n is 64. So when I put 64 over here, so 64 minus 1 is 63. This is approximate 9 quintillion. Okay, remember a billion. Then we have, before that we have million. Then million, billion, trillion. Then we have gazillion, and then we have quintillion. Getting? So it is approximately 9 quintillion. Okay, half positive, half negative. I hope it is clear to you guys. Okay, I've given the table. Byte takes 8 bit, minimum value minus 1, minus 27, minus 2 raised to 7 to 2 raised to 7 minus 1. Same way short. It is 16 bit. So minus 2 raised to 15 to 2 raised to 15 minus 1. It is total 64K. Remember, 64K means not 64,000. Means it is 64 into 1024. Because in binary, 1000, when 1K is 1024. 1K is actually 2 raised to 10. So 2 raised to 10 doesn't come out to be exact 1000. It is 1024. So 1024, if you multiply by 64, you'll get 65535. That is 36. So half positive, half negative will come this much only. Same way int, which is 2 raised to 31 to 2 raised to 31 minus 1. This is approximate 2 billion. And last is long, which is 2 raised to 63 to 2 raised to 63 minus 1, plus or minus. This is approximate 9 quintillion. Okay, so I hope you got it. Now, if you really want to print and see this range, really byte range minimum is this much, maximum. What Java has done is, all these 4 data types are having their corresponding 4 wrapper classes. Okay, so what they have done is, in their wrapper class, okay, we don't have to create this wrapper class. Don't worry. These wrapper classes are already provided by Sun in Lang package. I just want to tell you what they have done in it. Suppose it is a byte wrapper. Data type byte will have a corresponding wrapper class byte. B will be capital. Why? Because it's a class name. In Java, every class name starts with capital. Inside this, they have created two constants. They are static and they are constant, like this. Final byte max underscore value in which 127 they have stored, and similarly there is one more final byte min underscore value equal to minus 128, and many more things will be there in that class. Many more methods will be there, but these are the two constants. Name of the constant is max underscore value min. They both are byte type. They are initialized. As they are final, concept of final is once initialized, you cannot change them. You're not allowed to modify them because it is final. And finals are strictly initialized. Okay. And the other thing, they are static. Now, when they are static, they don't belong to individual object. They are shared by all the object. Listen carefully. All the objects share one copy. Only one copy of this both are created. And main thing is, as it is static, to access it, you don't have to create object. You can directly access it in the class name context like this. Byte dot max underscore value. Getting? You can access these members, this both, directly in the class name context as they are static. Directly class name dot. No need to create object of byte to access them. And similarly, they have created in the other class also. Like in short class also, they have created such max and min. They are variables of short type only. And in that, the minimum and the maximum, that is 3, 2, 7, 6, 7. And 3, 2, 7, 6, 8 is stored. Same way in integer class, same way in long class. Okay. If you want in JShell, you can print and see. Okay. I'll quickly show you these values. Byte dot min underscore value. Does it print minus 128? Same way. Byte dot max value. Does it print 127? Same thing, you can do it for short. S capital because it's a wrapper class. S small means it's a primitive data type and its corresponding class is short. Okay, does it print 32,768? Same way, max value. Sorry, and 2 times. Okay, it is printing. Similarly, you can try to print minimum of integer, integer, complete class name integer. See minimum, then its maximum. Okay, again I did the same thing. Okay, same way you can print minimum of long. See. Same way you can print maximum of long. Getting? So all such provisions Java has provided. Okay, so I hope this concept is clear. Then moving to character type. Now character and integer both come under integral type. Integral concept means both store whole numbers. Only the difference is integers store negative, positive both. Therefore, in integers, whatever the capacity is, half is positive, half is negative. But characters are unsigned. Therefore, whatever is its capacity, all are positive. Understanding? So, as an example, suppose I take my data is 3-bit, okay, unsigned integer. If I'm considering unsigned, not signed, unsigned integer. Okay, then in that case, tell me if it is 3-bit, so how many total numbers you will have? 2 raised to 3, that is 8 numbers. Their combinations we can show 0, 0, 0, 0, 0, 1, 0, 1, 0. Then because this is 2, then 3 is 2 plus 1, 3. Next is 4, that is 2 raised to 2 is 4. 5 is 2 raised to 2, 4, and 2 raised to 0. Getting? 5. 6 is 4 and 2. Getting? And last is 7. 4, 2 and 1. Now in this total we are having 8 and all are positive. Means here we don't consider sign bit. Getting? This decimal is 0, this decimal is 1, this decimal is 2, this decimal is 3. But in case of unsigned, when I took, sorry, in case of signed, when I took, from here I started treating them as negative because sign bit is coming 1. So from here I started taking 2's complement. This is not to be done in case of unsigned. In unsigned, no need to consider this sign bit, direct convert to decimal. So directly decimal, no need to convert to 2's complement. Direct decimal means 4, then 5, then 6, and then 7. So can you check? Capacity is 8, all 8 are positive. As all 8 are positive, the range will be like this: 0 to directly 7. Can I write like this? 0 to 2 raised to 3 minus 1. Why 3? Because just now I took example as 3 bit. So 2 raised to 3 is 8, 8 minus 1. In general, can I write this as 0 to 2 raised to n minus 1? And in case of character, we have to take this range. And remember, in Java, characters are 2-byte Unicodes. So it takes 2 byte, means how many bits? 16 bit. Understanding? So what will be the minimum value? 0. And what will be maximum? 2 raised to 16 minus 1. 2 raised to 16 minus 1 because it is 16 bit. Now 2 raised to 16 is 65536 minus 1 will be 65535. Means if you consider their binary, all 16 bits 0, here 16 bits, all 16 bits 0 till all 16 bits 1. Somewhere all 16 bits will become what? 1. Getting? And if I want to represent them in hexadecimal, okay, so these 4 ones will make 15. Is it or no? This is 15. See here, this is 1, this is 2, this is 4, this is 8. Getting? So 8 and 4, 12, 12 and 2, 14, and 1, 15. But how do you write 15 in hexadecimal? 15 in hexadecimal is F, 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 and F. So you can consider in Unicode form \U 0, 0, 0, 0. This 4 in hex I'm writing as 0, 0, 0, 0. 1 hex is 4 zeros, 4, 0, 4, 0, 4. Till last hex will be how much? \U F, 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 F. Why? Because it is unsigned. All are positive. Okay. So I hope that part is clear to you. See here. So character data type, char takes 16 bits. Minimum value is 0. Maximum value is all 16 ones. All 16 are ones. Remember, 1F means 4 ones. So 4 F's will make 16 ones. And all 16 1 because it is a 16-bit data. Last will be what? All 16 zeros to all 16 ones. And all are positive. You don't have to consider the sign bit over here. If the sign bit is 0, take 2's complement. No rule. This is over here. Okay? So the character type is clear. Then moving to floating point. Floating point are numeric only. They are numeric data type, but they are not whole numbers. So in this also positive negatives are there, but they are not whole numbers. They have decimal value also. And when they have any decimal value, that value which is after decimal is never accurate. Getting? It is truncated. It is round off to some places. We are going to round off to some places. So after that rounded place, If you have anything is truncated, so there will be a error. Error meaning not code error, the value error, precision error. It's called as precision error. Correct? Because it's never accurate. Now, how floating point values are stored in memory? Floating point values are stored in memory, obviously in binary form, but their storage pattern is different. Here, they are using some notation. It is called as IEEE. Okay, IEEE means Institute of Electronics and Electrical Engineers. They have created some standards, and the hardware making companies have to follow them. Okay, so IEEE 754 standard is there, and it is the standard for storing floating point number. So your computers will internally follow that standard for storing floating point number. Okay, how it is, that I'll tell you. It is actually stored in the Mantissa exponent form. I'll tell you, suppose you are taking one example as 23.21, suppose. It may happen that nothing is there before dot. It may be positive or negative also. It may be positive, negative. Before dot, you are not having anything, whatever. Now, first you have to convert this into binary. Remember, anything which is before dot, they will have value 2 raised to 0, 2 raised to 1. Their place values will be like this. But after dot, it will be 2 raised to minus 1, 2 raised to minus 2. Getting? It is 1 upon 2, 1 upon 4, 1 upon 8, like that. Okay? So first you have to convert 23 in binary. Now how you'll convert 23 in binary? Okay? You can go by traditional way. 2, 11, 22, remainder 1. 2, 5, 10, remainder 1. 2, 2s are 4, remainder 1. And 2, 1s are 2, remainder 0. Now from bottom I have to consider. Always before dot whatever is there, it's binary, you have to convert from, collect from bottom. That is 1, 0, 1, 1, 0. 1, 0, 1, 1, 1. Not 0. 1, 0, 1, 1, 1. Okay. Now the question is how to convert 21. Means 2, 1. You should not call 21 because it's not a whole number. It is everything after dot. So it is a rounded value. How to convert this 0.21 in binary? Here you have to multiply by 2. Okay. And this multiplication can keep recurring. It can keep go on because it will never stop. The values will keep recurring. The pattern will recur. So you have to stop till as many bits you want. As many bits you want, only till there you will stop. So what you have to do is you have to multiply it by 2. Okay, it will be 0.42. Okay, so take this 0. Take this 0 and now multiply again with 2 with the remaining part, whatever is after dot. What is before dot, don't consider. Just take that 0. Now you will get 0.84. Again take that 0. Again multiply by 2. You will get 1.68. Now take only 1. Okay. And now multiply only with 0.68. Don't multiply with 1.68. Take that 1 and now only multiply with 0.68. You will get 136. Isn't it? So 1.36. Again you will take 1 and only multiply by 0.36. It will be 0.72. Take 0. 0.72 with 1.44. Take 1. Then again 0.44. This will go on. Okay. So you have to collect. Now here you have to collect this binary from the top, not bottom. From here you have to collect. Top. 0, 0, 1, 1 and then whatever. So blah blah. I'm just putting 0, 1, 1, 0. Any number can be there. Now this is the converted binary. 23's binary is this and 0.21's binary is this. Now this number you have to normalize. How? Bring this dot to first one. Okay. Now it is possible that before dot nothing is there. then shift that dot to first one in the right side. If you are shifting it this side, you will get 2 raised to negative. And if you are shifting left side, you will get 2 raised to positive. So when I shift this dot to the first one, I'll get 1.0111001 dot 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 whatever is there into 2 raised to how many places shifted? 4 places. So I'll write 2 raised to 4. Okay. Now in this 4 is your exponent. Okay. And all these bits which are there after this 0, after this 1, they are called as mantissa. Now you have to store this mantissa exponent in the memory. Now, how it is stored according to IEEE notation? See here, if it is float, okay, how the storage is. 24 bits will be for mantissa, 7 bits will be for exponent, and 1 bit will be for sign. So if the number is positive, here you store 0. If it is negative, here you store 1. Okay. Now whatever is your exponent, what is your exponent? 4. Then 4's binary you store in this 7 bits. And these all bits which are there in the mantissa, 0, 1, 1, 1, 0, 1, 1. How many you will take? 24. After 24, cut off. Why? Because we need only 24. So after 24, if you cut off, so that is the error, no? Because they are never accurate. So here what we are going to store, this pattern 0, 1, 1, 1, 0, 0. That pattern I'll store here in 24 bits. Exponent I'll store in exponent and sign over here. So if it is positive, I'll store 0. If it is negative, I'll store 1. Same is the case for double. Only the capacity. Now, this was for float. Float takes how many bytes? 4 byte. Means 32 bit. Double takes 64 bit. So in that case, mantissa will be 52 bits. Exponent will be 11 bit and sign bit is 1. Okay, total 64. See, 12 and 52, 64. Only remember, if it is float, the precision is approximate till 6 digit. If it is double, the precision will be approximate 15 digit. Because you see, you know, the capacity only is changing and the exponent part bit is changing. So obviously the accuracy will be too high. Getting? Is the range also with too large scientific number or too small scientific number, then go for double. If it is not that large, getting till 6 digit accuracy but not too big or too small, then go for float. Okay, so I hope you got it how they are getting stored. So whatever your floating number is, before dot convert to binary, after dot again convert to binary by multiplying 2. Okay, remember here 1.68. So only take that 1 and next time multiply only with 68. You'll get 1 point. Next time take that 1 and multiply only with 0.36. Understanding? And as many you get bits in mantissa, from that only keep 52 and store, or keep 24 and store. Remaining are truncated. Getting? So the storage mechanism is clear how they are stored. If you read complete reference Herbert Shield, there also they have shown how in mantissa exponent form they are stored in IEEE notation. Okay, so if we have float, float is 32 bit, that is 4 byte. Its minimum value is 1.4 to the power minus 45. E, I have written in scientific form, na guys. E means it is 10 raised to 1.4 into 10 raised to minus 45 to 3.4 into 10 raised to 38. Actually, it is plus or minus, plus or minus, plus minus, plus minus. Can you see? And same way for double, it is 4.9 into 10 to the power minus 324 to 1.7 into 10 to the power plus 308. See how huge exponent it is. So, so large and so small value you can represent. Again, here they are plus or minus. And here also, if you want to print and see this minimum maximum, they have these two constants in their corresponding wrapper class, in float wrapper class and double wrapper class. Getting? I'll quickly show you. See here. Float dot min value. Is it printing 1.4 into 10 to the power minus 45? And there is max values. It is printing 3.4 into 10 to the power 38. It is written in scientific form, E. In the past session, we have discussed about literals. We have discussed about floating point literals, guys. Don't forget. Okay. Similarly, if you want to print minimum value of double, use double class. Okay. And same way, max value, print max value of double class. Okay. So this part is also clear to you, I hope. And then one last primitive data type is there, that is Boolean. Boolean speciality is what? That it cannot be converted to any type and anyone cannot be converted to Boolean. Getting? Therefore, it will have only two possible value, true and false. And what will be its internal memory capacity? So it depends. Some books, like if you read Balavuru Swami and all, there they have given 1 bit. But if you read Sun Microsystems documentation, there they are saying VM specific. Means it depends on the virtual machine. Means every virtual machine internally may take different space for Boolean. Doesn't matter. It anyway doesn't create any problem to us because we are only allowed to store true and false. One. And anyway, it's not going to create any problem with its capacity because it will not be used in calculation with the other data type. In any other data type, it cannot be used in combination. It is independent. You cannot convert Boolean to anyone, anyone to Boolean. Therefore, whatever the size is specific to VM. It is hidden. It is abstract. Okay. So, Boolean, according to some book, as I said, it is 1 bit. True value, false value. These are only the possible values which can be given to Boolean. Okay. So I hope the concept is clear to you. All the primitive data types. So here we have completed with primitive data types. Non-primitive we will be discussing separately. When we'll learn how to create our own class, then adding data in it, adding methods, adding constructors. That time we will learn non-primitive. Okay. So now some quick examples. See here. Which integral type in Java has the exact range from minus 231 to 231 minus 1? So see, this is 32-bit and 32-bit is whose capacity? Integer. Byte is 8-bit. Short is 16-bit. Integer is 32-bit and long is 64. So obviously this is the range of integer. So is it type byte, type short, type int, type long, or type char? It is type int. Okay. And which of the following do not denote a primitive data type? Remember, we have only 8 primitive. Everything other than that 8 are non-primitive. Okay. So here I have listed. Getting? Single quote K. It is a character literal. So it is a character type. Character is primitive. 50.5 F. It is float. Float is primitive. False is Boolean. Only this double quote T, or I have written double quote hello. Getting, guys? So as this is written in double quote, it is string. And remember, in Java, strings are objects. In the last session also we have discussed, when we discussed string literal, that remaining literals we completed, character literal and the string literal. So in case of string literal, and then I told you about that text block by writing 3 quote. That time I told everything what you write in double quote is a string object. String is a class provided by Java. It is in lang package. No need to import that package directly. And I can prove that it is an object by invoking a method. Here I can write dot length. So you can call method only for non-primitive. Can I call such methods for primitive? No. In the last session, we have done the comparison between primitive and non-primitive, guys. Don't forget it. See, if I take you back to that comparison, see here. When we did comparison, that time I told you cannot call methods for primitive, but you can call methods for non-primitive because they are objects. So they are reference variable. They don't store direct value. They store address. They store reference of object. And then you can call methods of that object. Getting? So that is the basic difference. Therefore, remember, strings can never be primitive. This double quote T, double quote hello. You can see here, if I write double quote hello, dot length, if I write round back, it's calling method length for that object hello. It will return 5. Or I am writing double quote hello dot to upper case. It will convert that hello to uppercase and return you new string hello. This proves that that double quote is a object and all objects are primitive, non-primitive. They cannot be primitive. Okay. Then which of the following primitive data types are integer type? Integer means whole number, positive, negative. See here. Boolean, not integer. Byte, yes. Float, no. They come under floating point. Short, integer. And double, floating point. So who two are in integer category? Byte and short. Agreed? Okay? So I hope this part is clear. Now we have to dive into very important topic, that is variable. Then we will be discussing about variable, variable declaration and all. Then types of variable according to their scope. In Java, we have only 3 types of variable: local variable, instance variable, static variable. So all that in detail we have to discuss. Okay, and then we have to start with a very important topic, that is operators. Okay, so first we'll talk about what are variables. So can we say variables are identifiers? They identify means they are the names given. Identifiers are what? Names given to different program elements, like name to your package, name to your class, name to the method, name to the variable. So obviously it's an identifier. You can say variable is a name given to memory locations. Means in your memory, some memory locations are reserved, and to that memory you are giving some meaningful name. Because to deal with this memory in the program with the address is very cumbersome. Getting? It is not at all possible to deal with the address in the program. So you have to give some meaningful name. And then how you will deal with this memory in your code? By that meaningful name. So you can say variables are name given to memory location. And the value in that memory can change. You can read this value for calculation. New calculated value you again can store. So as this value can change, that is the reason it's called variable. Okay. Or you can say variables are placeholders in the memory. Variables are placeholder, means they are occupying some space. Like in the colleges and school, we have benches. So students are occupying that bench for that class duration. When the class is over, they go, someone else come on that bench. So you can say that benches are like placeholders, right? Okay. So same thing here, you can say variables are placeholders in the memory and the value in that placeholder can change. Or in real life, you can say it is like a container. Okay, it is like a container. Container means you say like a box. Like from your Swiggy or Zomato, you are ordering some fruits or something. Then the box of that fruit come, right? And in that box, your fruits are there, and you open that box. The box will have the opening thing. I'm not good in drawing. Okay, so I hope you are understanding. You open it, and then something is there, you remove it, you use it, you can keep something else in it. Okay, so this box is like a container. Variables are also exactly same. Getting? So you can say they are like a container, and the value in that container can change. Okay. Now, what you have to remember, the speciality. Okay. In Java. And remember, every variable will have a data type, and that data type will indicate what type of value you can store in it. And that data type will indicate how much memory is reserved for that variable. Always remember, every variable will have a data type, and that data type will signify what type of value you can store in that variable, whether you can store whole number, floating number, character, what, or whether you can store a reference, means address of someone. Okay, so what type of value you can store, that you come to know from the data type, and how much amount of memory is reserved for it, whether 4 byte, 8 byte, 1 byte, 2 byte. So that is also decided by the data type. So every variable will have a data type. Okay, and remember one important point, Java is a strict type language. Okay, and Java is a static type language. Opposite of that is Python. Python is a dynamic type and loosely type. It is not strict type, it is loosely type. And Python is not static type, it is dynamic type. Okay, so I'll not talk about that. Why we call Java as a static type? Because in Java, you cannot use any variable without its declaration. Means if I want to use any variable x equal to 10, I cannot directly start assigning the value to it, which is possible in Python, JavaScript, PHP. They all are loosely typed and they are all dynamic type. So directly I cannot start assigning. First, prior, I have to declare it. And declaring means you are telling the name of the variable and the type of the variable. Means in short, when we say a language is static type, when the name of the variable and the type of the variable is announced at the time of compilation. I hope you know it. Compilation and interpretation. Interpretation means runtime. So during compile time only, you have to announce before use. Before use, you have to announce the name of the variable and the type of the variable, so that according to the type, that much memory is reserved for that variable. How much memory is to be reserved for that variable is informed at the time of compilation to the compiler. Understanding? That is the reason it is static. Getting? So when you say a language is static, the language in which you cannot use variable without declaration. And declaration means what? Informing the name of the variable and the type. If you mention the type, that much amount is reserved for it. And optionally, if you want to initialize also, you can by giving equal to, and then you can assign value to it. That value will be stored in that memory. Okay. So static, why? I hope it is clear. Data type known at the time of compilation. At the time of compilation only, you have to tell the data type and the name. Before, without declaration, you cannot use any variable. Therefore, static. And why we should call it a strict? Because once the variable is declared of some type, let it be int type, float type, whatever, throughout its lifespan, it will be of that type only. Getting? This principle should be followed by our politicians, right or no? So depending on the election, they keep changing their party. There are some people who are there that they never change their party. They are born in X party, till their death they are in their X party only. So suppose if the variable timely changes its type. Now I have stored 10, it's integer. After some time I am storing double quote Ram. It has become string. Okay. After some time I am storing in X only true. It has changed to Boolean. It's like chameleon. Girgit we have, in Hindi we call it as Girgit, or in Marathi we call it as Sarda. Getting? So like a chameleon, it's not like a chameleon. it is changing its type according to the situation. Such thing won't be allowed. This is wrong. It is not, it is illegal in Java. Once the variable is declared as integer, throughout its life it is integer. Means in this variable, I can only store any integer. As it is integer, I'm allowed to store int only. Sometimes I'm storing string, sometimes boolean. It is wrong. Compiler will give error. That is called strict type. So strict type means once the variable is declared of some type, throughout its life, it is of that type only. It cannot change its type timely. Timely, it keeps changing its type is not possible. That is strict type. And static type, without declaration, you cannot use. And at the time of declaration, means at the time of compilation only, you are announcing the data type. Okay, so that is the speciality. So we will first discuss about variable. Okay, then we will discuss about uh, how the variables can be created in different way, and the syntax of declaration, everything one by one. First, we'll just see the definition. So variables are containers used to store data in the memory during execution. During execution, your values keep changing. So that values you are keeping in that container and you are giving name to that container. And where is that container? In the memory. Think of a variable like a labeled storage box. Just now I showed you, from your Swiggy or Zomato, you have ordered fruits. So you have ordered mangoes. So now the 2 mangoes, 4 mangoes come in one carton, right or no, in that box. So when you open it, that mangoes are there. You can remove that mango. In place of that, you can keep anything. So it is like a box, but it is a storage box in your computer memory. You can say variables are the name given to memory location. Means in your memory, some memory locations are reserved, and to that you are giving some meaningful name. Okay, okay, and the value in that memory location change. See, variables are placeholders in the memory, and the value in that memory change. As it is changing, that is the reason we call variable. Okay, then note, Java is a static type language. Static type meaning the data type of that variable is to be told at the time of compilation, so that that much amount of memory is reserved for that variable. So note that Java is static type language, meaning no variable can be used without declaration. You cannot use variable without its declaration. And declaration means what? Informing to the compiler the type and the name. Okay, see, a variable declaration means telling Java compiler the type of data, means what type of data you are going to store in it. Possibly, if it is primitive type, then in that container you are storing directly value. If you have created, means you are creating like this, integer age. So this is declaration. That's what I'm saying. Variable declaration means telling compiler the type of that variable. So the variable type is int, means in this age what will be stored? Integer. Getting? But it can be a non-primitive also. It's not necessarily primitive. Means in this, the name given is age, and directly in that what is stored? Integer. But if it is non-primitive, cat, money. Getting? And remember, without new you cannot create a copy. But in this case, that money is not going to contain direct object. It will contain reference. And somewhere on the hip, cat is created, in which cat color, cat height, cat weight, cat breed, whatever is there, total memory allocated and the reference. Okay, so whatever it can be primitive type, it can be non-primitive type. Okay, so remember the type of data, that is the data type, and the data type is known at the compilation time only, therefore it is called static. And the name of the variable, okay, general syntax is like this: data type, variable name. This data type can be primitive, non-primitive. If it is non-primitive, it will contain reference. If it is primitive, it will directly contain the value of that data type. Okay. And optional, you can give initial value to it. You can assign also. So see here, you can assign value to it by equal to. So whatever you assign will get stored in it. So it can be primitive value also or reference also. So variable initialization means assigning a value to a variable. See here. After declaration, you can initialize variable name equal to value, and you can combine this both by, you can combine variable declaration as well as initialization like this. Data type variable name equal to value. So at the time of declaration only you can give value. Both possible. And again remember, Java is also a strict type. It is static type, no doubt. Static type, why we have to call it? Because without declaration you cannot use variable. And declaration means at the time of compilation only you are telling its data type and the name of the variable. And strict type means once you declare a variable of some type, throughout its life it is of that type. You cannot change its data type. Getting? So means once variable is declared of some type, then throughout its lifetime it is of that type only. It cannot change its type. So syntax of declaration you got, declaring and initializing you got. Then this data type can be primitive and non-primitive. Then you know why we call it as static type, why we call it as strict type. Okay, so all these things are clear to you, right? Then in that variable you can store reference also and value. So that we'll be discussing in the next session. Then I'll be telling you about the types of variables according to their scope. In detail we have to discuss, and then we have to dive into a very new topic, that is operators. When operators get over, then we have to see control structures like if else, for loop, while loop, do while loop. That thing is over, then we will dive into classes and objects. Getting? Then classes, object, then construct, inheritance and interfaces, all that topics will come one by one. So it is a kind request, attend sessions every day. By some means you are not able to attend, at least watch videos. Remain in flow. Okay? Be in the flow to make your whole learning process easy. Because lot of many advanced things you'll be learning later, based on which you'll be making projects and you will be appearing for the interviews. So lot of advanced concepts you'll be learning, and for that all these are elementary things. Okay, so for today we will take a pause over here only. Okay guys, thank you all of you.